Hello and welcome to the Tech Lunch Podcast, where we encourage our listeners to learn something new about tech every week. This can range from learning about new and exciting applications to the advancements in coding and technology. If you are always learning, you will always be a step above the rest. Take the time during lunch or during a break to listen and learn, kind of like a lunch and learn, but for the ears. This podcast will open the listeners' ears to new and exciting technologies they may have not been purviewed to in the past. These topics will range from manufacturing technologies to data collection technologies and everything in between. Hello, I'm Nick.
Hey, I'm John.
Hello, I'm Ed.
And this week we're kind of talk about, something a little bit different, and we're really going to aim on, with the mindset of improvement. We're really thinking about, how you can get into that mindset, where it pertains from there. So, John, I'm going to turn it over to you. When you're kind of thinking about that, what's popping through?
Yeah, thanks. The biggest thing, we've actually talked about this a lot, Nick, and you've kind of, to a point where you've got a little angry that we're not doing it. It's the proactivity versus reactivity. I know we've harped on like the 3D printing, and I do kind of want to stick around a lot of that processes and improvement on that side. But it's okay. I've got my print. I've got what I've started printing. I might be having problems here or there. How can I improve? What do I need to improve? And I think Ed actually, honestly, you probably run with this for weeks, to be honest, because I didn't get five steps in the door before we had some type of improvement already, that you're like, why can't we do it like this? And that mindset is kind of a driving point for me. And kind of should be an underlying thing in not just 3D printing, but everything. But we want to try to bring that, or at least I would like to try to bring that into the 3D printing idea. So what's my next step? So I have the thing, it's printing. How do I make my print professional quality as opposed to a hobbyist that still has defects everywhere, but is, acceptable for yourself? You're not distributing it. And then you can kind of step that quality into, if you want to start a business, how can I make that quality high enough to where you take a step back and think, if I was a customer buying from this 3D printer or this manufacturer or this supplier, if you're thinking industrial, why would I choose you over someone else? What is your quality? Mm-hmm. What is your strength and all that stuff? And how do you kind of go about improving that? So, I mean, Ed, I think we've talked about it a lot. You've talked about it on sensors, temperature gauges, and things like that. You've talked about it with pulse width modulation things. What do you think about whenever you take a peek at, let's say, a printer that was built with a kit, and it's like, okay, this is what was generically given to me, and I've printed with it, but what next? How do I make this better?
So from my perspective, is people have always purchased cars and made cars better. And that's basically by, adding some things to it, adding performance things like, hey, I'm adding high temperature spark plugs, silicone based spark plug wires, adding a different turbo, or tweaking the firmware. So for me, that's where I'm starting. I'm starting with, hey, what are the simple things that I can change software-wise? What can I do in the firmware to automate some things? Because as we all know, leveling a bed is one of the biggest headaches for people that enter this field, or into the hobby. And then also the deviation you get from the bed when the temperature is at a certain temp. So those are things that I think about, like how can we automate that process? How can we make this process use machine learning and leverage that with things like maybe MQTT?
Yeah, bring your standard deviation to zero.
Yeah, or hey, maybe why is it necessary to have a GUI when I have a mobile device? Why can't I use a tablet? Why can't I use my phone? Why is it necessary to have a OLED here? Why is that necessary? Why can't I just use a web-based app? Why can't it just be a mobile app? So these are things I'm saying is, hey, maybe I can take those resources from here and not use that on my power supply, and maybe I can use that for a different application where, hey, I can use this for, I want to leverage data. I want to do analytics. I want to build analytics in. I want to look at every model that I build or every piece I build, and where did I go wrong? How can I learn better? And the machine teach me, and I teach the machine. So I think that's something we could use. And what do you think, Nick?
Me, I'm really big on the future proofing stuff. But, however, like John brought it up, I am the proactive type of person. My background is in software testing. So, when I start looking at something, that's the first place I'm headed. Is I'm going to look at the firmware, I'm going to look at, that type of stuff, and I'm going to try to be proactive. If I know that, my standard deviation is, plus or minus 1, I'm going to try to get that down as low as I can to plus or minus 0.1, 0.5 or below. Right. Depending on what my, comfort level of shift is, at that point. So, for me, being, an IT guy, I'm digging into the code. I'm digging into, smoothing things out and moving things out of, reducing unneeded movements and speed. Because the thing is, what's slow is fast, fast is slow. It's just, just got to be smooth with it, because everything has an abrasive to it. And, with that, if you can take out that abrasiveness of, 95% of your push with your movements, left, right, lateral limits, up, down, coming up, if you think about how smooth that is, the extruder is moving that much smoother. Your definition is there. You don't really have an availability for error. You kind of work the error out. You kind of be proactive on it and push the error out of the process. And sometimes, I'm not saying it always starts in the firmware or anything like that, but I mean, it's a good place to look because there could be bugs. And, it's like tested to its fullest extent, and then, that's just be proactive to the problem, and instead of being reactive, to, like you've said multiple occasions, now I'll have a freaking, 200 spaghetti monster sitting on my hands. What in the world do I do with the darn thing? And you're being reactive to fix a problem that you should have caught at the beginning.
Yeah, exactly. And Ed, when you were talking about it earlier, it's actually fantastic that you brought that up. Wrapping in MQTT into how you can improve. Like, I know this could, for some people, it ends up being like high level advanced, but honestly,
preventative maintenance.
Yeah, it's preventative. Yeah, it's absolutely preventative maintenance. You like right now, most hobbyists are going to be doing, like, they do print tests, like a first layer test or a shell test, and I measure that test with my calipers and see, like, is this dimensionally close to what it should measure, what's my accuracy? And I'm doing that manually, and then I put it into an equation, recalculate my flow rate, and then I readjust that on when I do my print. Now that's a bunch of manual moves, and it is very tedious, and I've got to stand there waiting for the print 10-20 minutes each time to continuously adjust, wait for this test to finish until I get it right. Once I get it right, that thing's going to probably be printing for maybe a couple months, maybe a couple weeks, depending on what I'm doing. But with that same mindset, I've got to do that myself, and that's a manual. I don't like that. I don't like that really very much at all. I would like that to be automated. Like we've kind of touched on Octopi. Mm-hmm. It's something that exists so that you can kind of keep an eye on your printer and adjust things while you're going. But it also has the MQTT, in that sense. Why can't the MQTT dictate like what you were saying? You want it to stop before it's a spaghetti monster. Why can't it dictate like what my dimensional accuracy should become? And I don't think there's anything like that, to be honest with you. So if that's something that we want to step forward with, like that's a great like possibility. That's within reach. And
the thing is that you're hearing them talk about a lot of the Octopi stuff and stuff like that. We'll do another episode on Raspberry on the 3D printer management side of the house. Because you're going from software slicers and stuff like that to now dealing in the management realm. So if you think about your 3-tier software approach, you're up at the top of that. But you know, pulling all of that, and you know, Ed will probably agree with me on this one. You know, we'll see. If you think about it, a 3D printer is like the perfect marriage of IT and OT. You know, look at what you're looking at, and the thing is how you know when an IT guy gets a hold of it, because there's a bunch of random stuff attached to it. And now for some certain reason, you know, it tells you when it skips.
Yeah.
You know, OT guy gets a hold of it, and now the thing runs like Mach 4.
Yeah.
You know, depending on who replaced what got
Get a new
replaced
belt
where.
system.
Right, exactly. You know, it's running down the highway, you know, printing somebody's tires for him.
Yeah.
You know, you got to be proactive, right?
You know, got a new tire line coming out soon. We're going to be printing in TPU. So, yeah.
So as always,
Anti-flat tires.
There you go.
So as always, I have to be the oddball. So because my mind, that squirrel runs on the wheel, and sometimes he falls off and get trapped in the wheel. But hey, it happens. So for me, here's a curveball. So what if I'm able to take advantage of when a 3D printer is printing a piece and capture that data via MQTT? However, what if I was able to do the same thing without dispensing any film? What if I was able to take a first print and incorporate that with TinyML and then do augmented manufacturing? So augmented manufacturing to me is, hey, I can take and simulate this whole process, moving these motions. I already know that the bed, by using sensors, maybe I use a strain gauge to figure out the deflection of the bed.
Yeah.
Now I got that information that I can feed back into an algorithm that I can use augmented, not augmented reality, but I would say augmented automation or augmented manufacturing. And what that does is that allows me to go through and make all the movements, and I can figure out where I would be off at this temperature because I already know because of the deflection of the bed what I had, and I was able to actually take with a camera or something to view where I was off because I was monitoring this the whole time.
Yeah.
So these are things that I think that if you start to incorporate these things with IoT sensors, if you start to incorporate these things where you actually use physics to your advantage and not worry about the disadvantages when you have to use physics, I think then what happens is you do it, it's a one-off. I make a template and I it's almost like set and let it go. Yeah. It's like a machine setter. Machine setters or two die guys set it up one time and then we just verify when we get off, or if it's damaged, then we make some adjustments. So I think that's where hobbyists should be striving to get. I do it one time, and then I have a calibration process that verifies that I'm within those parameters.
Like a ghost mode.
And it lets me know when I'm outside of, exactly like a ghost mode. When I'm outside of those parameters, it let me know, hey, you need to verify the bed again. You need to verify the process again. You need to verify the extruder again. You need to verify whatever again.
Right, yeah.
And the funny part is, I hate to jump in, but, we talked about it, I should say, a couple months ago now. We kind of talked about, the need for virtualization for the lines, like how you would do a line test. When you're doing virtual commissioning, stuff like that. So pretty much you're doing a virtual commissioning standpoint on a 3D printer. Heard me, talk about, bring it up, ghost mode. Yeah. Why can't we, like what Ed was saying, why can't we use ghost mode? I think that's, something that is absolutely needed. But now if you take ghost mode, we know ghost mode in the land of, robotics, and what that does. But if you think about it, what I'd like to do is, and this is just me thinking outside the box here, because I like do a little bit of proactive stuff, and if I can future-proof at the same point in time, sure, why not? Is why can't, when we're running that ghost mode, be able to send a MQTT message saying you're outside of normal, readings based on movement, flexation, and stuff like that, and stuff that you're dealing with. But also, we're talking about servos and stuff like that. We're talking about small motors that we're dealing with inside a 3D printer. However, we think about industrial control systems. some of those industrial controls, some of those motors have MQTT on board. Why can't we have a small MQTT set on board those smaller drive motors that'll still report back and tell you the status of your entire machine?
So you can have that, and then we're gonna let Champ chime in. You can have that with the controller.
Yeah.
It's a little bit more difficult to build that into an electromechanical device. You can build it on the back of it, like the encoder.
Yeah.
That you would use with a servo. So
Yeah.
yes, you could make the encoder. The sensor would have the intelligence, but the actuator normally doesn't have that much intelligence. Doesn't mean you can't do it.
Yeah.
But it's possible.
What about for the drive motors?
Even the drive itself is the intelligence.
Yeah.
So the sensor in this case, when we're talking servos, we're talking steppers is different.
Yeah, stepper motors.
If
Because I think that's what
we're
we're
talking
using.
stepper motors, we're talking different. Then you leverage that in the firmware on the board.
Oh, okay.
And in the firmware on the board, you set up a MQTT broker.
Okay.
And you can do all that
Yeah.
via the firmware.
Okay.
Yeah, and actually that's beautiful because I know we're going to get to Octopi later on, but that's kind of roped right on in there because somebody had the bright idea of, well, why are we working so dang hard on something when we can have the computer and the machine work for us? We upgrade the motherboard, we upgrade the RAM. Now it can process. You slap a Raspberry Pi on there, and I think it's hilarious that Nick said it's the marriage of IT and OT because you're absolutely right. As soon as I got this thing, I'm slapping extra pieces on there to connect it to get it more connected to the internet or not even just the internet, but more connected to, my other computers so that I can run things, throughout the house, right? I can take a peek if I'm in the kitchen and looking at my printer, but we'll get into that stuff later. Kind of taking a step back and talking about the MQTT feeding in and reporting back to the printer. Who's to say you can't set up a database, do some numbers, and you come up with something materially let's say currently they're making it with maybe steel, copper, brass. They're making those connectors or those heat breaks, right? Who's to say you don't take those measurements and then realize that maybe there's a better alloy that can mesh with the temperature change, because it is drastic temperature changes. You're going from room temperature to 200 plus to 260 degrees Celsius, and that's now I know we don't use we use the Fahrenheit here. That would be in the 300s, 400s, getting close to it. That's absolutely ridiculous. And if we can figure out how that another alloy can behave in those long-term uses, I've done thousands and thousands of prints, how long does this last? You can also determine your lifetime of your entire machine, and then you can game plan your preventative maintenance, like you said, Nick.
Yeah.
So and all of that is run through a database, which you can then have Python running scripts and telling you when something needs to change. So then it's crazy how much you can get into that IT side. Now, as far as the OT side, to me, this is where you can see I'm a little bit more IT than OT. It feels like more maintenance and more work, and I'm like, why is this not automated for me? And then let's get a PLC in there and then have it on there too.
Yeah, then it's all a bunch of games, funds game.
Yeah.
So I would say just this. So the oil companies leverage this for the last 20 plus years.
Yeah.
It's called down the hole data. So basically, we can say is down extruder data. You can take down extruder data and use those, like you said, in a database. And Nick can probably elegantly explain how you can do those things.
Now, it's kind of funny. You start bringing up the metals and the alloys and stuff like that. That's when I start thinking about Iconal. Iconal, metal alloy is, currently what's used by, suppressor companies to build suppressors for the U.S. military to combat. They dissipate heat really, really quickly. And they're some of the most robust alloy on the planet.
Yeah.
That thing can take a beating and keep on ticking. The thing is I have not seen that get brought into the world of 3D printing yet.
Exactly.
Technically, you can make that into nozzles and stuff like that and go that route. However, Iconal is very expensive.
Yep.
But you may only have to buy one nozzle every 3 years.
What if you could 3D print alcohol?
Yeah, right.
If you can, then you're going to put some people out of business.
Yeah, you
I'm saying like
take relativity space out.
I'm not saying that we're aiming to do that.
Yeah.
But the whole ideal of hobbyists is the same ideal of the people that were able to take PCs and components apart and figure out how they work and make them better.
Well, if you think about it, everything that we're talking about now is exactly what, like what John just mentioned, relativity space. Exactly what they're doing right now with a KUKA Robotics arm and a welder, 3D printing using their own alloy, a rocket. Not just a nozzle anymore. We're building the entire rocket. So you're kind of going off the the deep end here. But if you think about it, it's one of the newest ways for rocket manufacturing that we have now, because it's done quicker. It's also done with more precision. Yeah. But if you think about it, with everything they have installed, probably, can't confirm nothing what they have. However, if you think about it, even if they're running MQTT on board their robots, which we know, KUKA does support that.
Yeah, they probably do.
You now know, everything that's going on, and the thing is, you start talking about the down the hole data. Down the hole data is one of those things of, I've got my data from topside, and now I have to transmit that data from the brain of the people up top and the instruments and the reporting material all the way down to the drill head. Down at the bottom, telling me what I want it to do, what speed I want that thing to run at, and all of that, But the thing is also then you have, return data that comes back up out of that wellhead. When they cap those things off, it's sending data. It's telling you what's going on.
And the beauty of the what we call down the hole data for the oil company is they were measuring pressure.
Yep.
They were measuring temperature. And then they also were measuring position, GPS.
Yeah, it's like a sonar drop.
So also what they were doing is saying, hey, in this material we had this problem and we failed here.
Yep.
So now you're able to say, hey, I can work on designing better materials to drill with, stronger, lighter, more robust heads. And that's the beauty of it. So what I'm getting at is, it's perfect for if you're always having to manipulate. For me, a 3D printer shouldn't be, I got to change, I got to tweak this and turn that. I shouldn't be a gauge guy. I shouldn't be turning this valve and that valve to cut this on to balance out stuff. I should have a device to do that. I know what it has to be. This is the device to do it. So, like, I'll give you an example. The bed. Why are we heating up the whole bed? It's a waste of energy. That energy is being wasted in the form of heat, which is watts that you're using in your outlet. Why can I not concentrate that energy to a spot and figure out the mass of what I am trying to heat, calculate by the slices that's already made inside the machine, and tell me how much heat I need per layer. And then how much heat do I have to put up the stack to keep it that temperature. Maybe the thing is not cooling it down. Maybe the thing is heating it up, keeping a constant temperature. So what I mean that cooling it down, of course we still have to cool down the piece around it.
Right.
However, maybe I conceal this and keep it at a constant temperature. I don't use a bed. Whatever benefit I'm getting from the temperature of the bed in watts, why can I not make that like in a AC system you have in your house? When you turn the temperature up or the heat based off of what the temperature is outside.
Right. Makes sense.
Why don't we do that? And then how more efficient would that be? How much power would you save?
I mean, I definitely agree, because the first thing when you brought that up I thought of was efficiency. Was because you're absolutely right. If I've got, a bed that's 230 millimeters by 230 millimeters, roughly 8 by 8 foot or inches, and I'm printing something that's like, square inch, like, why do I need to heat up this entire print bed? Like, why do I need every single part of this to be at temperature? And right now it exists. That's how it works. Heats the whole thing up, and then the only time that it changes and starts to print is when it hits a temperature. It's ready to go, and it's maintains that. I think the big problem though currently now is there's only one connection there for where it heats up. If you add a couple more connections, a couple more wires, yeah, it'll be a little bit more, but you can then pick and choose in your G code which heating element
So now I'm gonna challenge you.
starts.
What if I made an IR bed?
An IR bed. Oh,
What if I use infrared and I can cut on banks of infrared to get whatever temperature range I want?
you also just gave me an idea. Induction is a thing too to heat things up. So why is so
You
these?
print with metal now?
Well, I mean, relativity space is printed with metal, so
That
why
is
not?
true.
But
That is
no,
true.
yeah, there's these other different ways to get the temperature rather than the conventional means of just putting a hot thing on it.
You could make a infrared grid
Yeah.
that was inside, and you could heat it, that infrared grid, and cut on which bank of infrareds you wanted for a time span, which I could really do with pulse width modulation. So I could also control how much power I wanted to put on that infrared bed.
Yeah,
Or if I was really, like feeling frisky, just go microwave.
there you go.
Yeah, that'd be fine and all, except for the whole cancer-causing properties that gives the user.
No, it does cause cancer problems because
Well,
if
you
I do
turn it on and go in the
if
other
I do
room.
the same
Yeah,
thing,
you just
if I
leave the
do
room
the
and
same
have it
thing
turned
with a
on.
microwave, if I do the same thing with a microwave, I can 3D print it in a microwave.
Yeah. They've made it safer for you to stand in front of your microwave, so why not?
Yeah.
And then there again, I can control the amplitude. I can control the time span. I can control the amount of energy that I am using.
Mm-hmm. See, and that's going back to that whole idea of what Nick talked about, saying mindset of improvement. Every one of these things are probably not like in actual like circulation now, but these are just like ways that you should think about, kind of thinking outside of the box and how can I improve this process, because you get the same thing and then it's like you get the printer that's the do-it-yourself kit and you start printing and you're like, okay, like I've just gotten past that first like serotonin hit where it's like, okay, it feels good to make something now. Then it's like, what's the point from here?
Yeah.
So like it's a great mindset like to push.
It's just,
it's
just the idea.
If you think about it, it's right now you're dealing with like definition of insanity.
Yeah.
You're doing the same thing over and over again, expecting there to be a change in result at the end. Yeah. And all you get is the same thing over and over and over again. The thing is now it's time to inject. Inject the the change in there, and watch that take effect. Yeah. Be prepared for it. Understand it and stuff like that. But I'll say that this brings us to the end of today. And from my side, I'm going to turn it over to whoever wants to take it. But I want to thank everybody, who's listening globally, from around the world and all over the United States. We highly appreciate it. We hope you guys, learn something and get into it. We're all over all the different things. We're starting to slowly but surely release some, 1-minute videos and some YouTube content over on the YouTube channels. So, hopefully y'all check that out, and I'll turn it over to one of the guys for the end of the run and whatever the charge of the week is.
So, like I said, as Nick said, I appreciate all the support we all do. Just a small update. We have bought some of the components for the 3D printer challenge. So we hope to have all the components, and we'll actually do a couple of short videos to show you what the components are. And then we hope to start building the printer and proving out our concept. And we'll let Chance take us out.
All right, and just to echo what both these guys said, thank you to everyone listening. Thank you for giving a platform, or at least giving an ear. Just listening is enough for me. Just get that thought process going. It's beneficial for everyone around you as well as yourself to want to improve or try some new things, and if you get something out of it, then it's all just positive. So we appreciate it, and we like they were saying, the content's coming out. It's going to be there. But if you guys have like any ideas or challenges. Like, we honestly, I think Ed would probably welcome every single challenge sent his way. So even though we're doing that 3D printing project with the building the printer, why not have another challenge in the works? So if you guys think we can't do anything, or want to try any of those ideas, just give us a shout. Just let us know.
Yeah, always keep learning. Mm-hmm. So, all right, y'all. Have a good one.
Thank you for listening to the Tech at Lunch podcast, where we hope you learned something about tech during your break or during your lunchtime. If you did, please give us a follow to prevent missing future episodes. If you have any ideas or something you want to hear or learn about, please send us a show idea to podcast@vulcanara.com. Hope you have a good rest of the day and continue learning.